Hi guys, nice to meet you. So my name is Sören. I am the co-founder and CEO of a company called Terramate. I'm all about Terraform, and I've been speaking on platform engineering a couple of times beforehand, always Terraform related topics. My personal background is in software and cloud engineering, so I've been working in this field for many years, I believe 15 years, something like that right now. And yeah, I run this company I mentioned already, Terramate. We develop open source around Terraform, now also OpenTofu, which I will briefly cover in this session as well. And I'd like to today talk a little bit about the problems of monolithic Terraform environments or projects and how to basically amplify those with stacks and code generation. I will leave the slides overseeable and also go a little bit more into a hands-on demo by the end. Let's see how much we can cover, how fast we can go. Please feel free to ask any questions that you may have by the end of the session. More than happy to answer all of those. In any case, if there's not enough time, you can also reach me, as mentioned by Maria already, in the platform engineering community on Slack or our Terramate Discord, or hit me up on Twitter or LinkedIn or whatever format is the best for you. Let's dive right in. So today's agenda. We do a little introduction, what we talk about, and the common pitfalls and obstacles, especially when it comes to scaling Terraform projects I'd like to cover. Then how to overcome those, and basically followed by a demo. All right. So hopefully everyone that joins this call knows what infrastructure as code is, but if you don't, why infrastructure as code? And I keep repeating myself in every single session that I do, but basically ISC and the various technologies out there enable us to build change and manage our infrastructure in a safe, consistent, and repeatable manner, right? And we do this by usually defining infrastructure as configurations that we can version, reuse, share, aka checking this into Git. We can also follow advanced patterns such as static code analysis, for example, do cross prediction on our infrastructure code, threat and vulnerability detection and whatnot. And some of the leading toolings in that space would be Terraform, which I believe is the big elephant in the room, being pretty ops-centric. Then Pulumi and CDK, among a few others, CloudFormation, for example, being another one, that are rather developer-centric. Yeah. Then about Terraform. So what is Terraform? Today's talk will be all about Terraform. Terraform is basically an infrastructure as code tool, as I mentioned in the previous slide. And in comparison to Pulumi, Terraform comes with its own configuration language called HCL, HashiCorp Configuration Language. It's declarative and yeah, basically follows the paradigm of infrastructure as code. It's been around for somewhat like 10 years, and the beauty about Terraform is that basically you have different providers for different cloud platforms or APIs. So meaning we can use Terraform to manage AWS, Google Cloud, Azure, but even SaaS providers such as Datadog or GitHub, for example. In my own company, we manage our own GitHub organizations with Terraform that basically allows our teams to easily create and manage repositories with sane defaults. Yeah. At this point, I quickly want to excurse to OpenTofu. What is OpenTofu? Basically, a couple of weeks ago, HashiCorp announced that it would change its license from MPL, open source license, to business license that is not open source. OpenTofu, I believe, is a community movement that basically is a fork of Terraform maintained by the community and contributed to the CNCF and Linux Foundation. The ambition here is basically to keep Terraform at its core open source, maintained by a few industry leading companies. I personally am involved in this project, so some sort of personal motivation and bias here. Of course, check it out if you would like to maintain on an open source version. And we try to keep full compatibility to Terraform here. So let's talk a little bit about Terraform, common pitfalls and obstacles, especially when it comes to scaling Terraform. So look at the time, 7:10. So the biggest problem that we see over and over again is basically the lack of stacks in Terraform. And what does that mean? Okay, in Terraform, every resource that we manage with HCL, with infrastructure code, directly maps onto one or multiple API endpoints in whatever platform or vendor of your choice you manage. So for example, let's assume you are managing some sort of cloud account. Could be a Google Cloud project, an AWS account, or an Azure subscription, right? And you manage multiple resources or entities within this account with Terraform. So typically, what would that be in a straightforward abstract manner? A VPC, so virtual private network, maybe some sort of database that you need in order to persist data, and a Kubernetes cluster that you need in order to run your applications. So now the fact that those are all managed within a single stack, within a single Terraform state, or basically code base, means that whenever we apply changes to this code base or to the state, Terraform would typically iterate over all those resources. That also means that the more resources we add to our code base, to our Terraform state, the more those runtimes in order to execute Terraform would basically scale or increase, right? Meaning many resources and many complex resources that may map onto multiple API endpoints, the longer the runtimes of our Terraform invocations. And typically, that is something, whereas if you manage smaller environments, the impact is neglectable and not as bad. But now if you start managing multiple cloud accounts or multiple environments, environment, for example, could directly map onto accounts or regions or whatnot, depending on your own cloud strategy. Those runtimes in terms of invocations would take longer and longer, and quite quickly this become blocking. So what would the direct impact be? The bigger your state, the bigger your code base to manage, the longer the CI/CD workflows, which basically also directly reflects on the lack of collaboration, because now if the CI runs, one developer adds a change to your code base, invokes the CI run. This would basically mean that all other developers are blocked in the sense of their code changes would be queued in your CI/CD system, right? And this gets pretty expensive. So let's say a smaller change may still result in 10 to 20 minutes CI/CD runtime, which quite often, depending on what kind of CI/CD provider of your choice you're working with, could directly translate onto costs, right? Because typically those are built at the per minute basis. It also means huge blast radius, because now every time we introduce changes to an entity such as a Kubernetes cluster, this can potentially have a big impact on your entire environment. It also means it's really hard to define ownership and separation of boundaries. So now if everything is managed in a single code base, it's typically, and there are mechanisms in place such as code owners and GitHub, for example, it's typically very, very hard to define who can work on what or who should work on what. And as mentioned in the beginning, hard to collaborate in parallel. So that's why we typically introduce stacks, or why we typically want to introduce stacks. So stacks basically means, in easy to understand words, we want to take monolithic code bases and split those up into smaller and isolated units. And if you look at this example down here, we see the same picture, the same example that I've shown in the previous slide. So basically, instead of having the VPC, the database in the Kubernetes cluster in an abstract way, managed within the same state, within the same Terraform project, we would split this up into multiple stacks. And that, for example, can mean that now we can introduce changes to those stacks in parallel. We can also, sorry, let me go back here. We can also detect what stacks contain changes and only execute those stacks. And it comes with a number of upsides, but basically enables us, and I'll show you some examples by the end of the slides, basically enables us to scale our Terraform projects without always running and considering every single line of code. So now we understood what stacks are, and we understood what problem stacks are solving. But then also this introduced a set of new challenges. So now, for example, if I split up my environments into stacks, quite often, if I work in big environments, I typically have hundreds of stacks, maybe thousands of stacks. Now, we'll take a look at this a little bit later. So now, typically, if I introduce changes to subset of my stacks, I only want to invoke commands, aka Terraform, OpenTofu, or whatnot, within those stacks. Meaning, if one group of developer introduce changes to the Kubernetes cluster, only this stack should be considered by the CI/CD. Otherwise, we haven't really added any value here. Also, in the sense of Terraform configuration, that means typically we add some sort of overhead in the sense of code duplication. For example, in Terraform, the typical dryness, do not repeat yourself vectors would be provider and backend configuration. So one of the most common questions, if we start thinking about splitting up Terraform environments into stacks, is how do we actually size those? And there are different factors to consider, just to mention a few of them. So it always sort of reflects onto how your cloud strategy looks like. But typically the question that you want to ask yourself is, okay, how many resources should be managed within a single stack? Whereas I typically follow a paradigm that says as little resources as possible. So typically I group a server and maybe some sort of firewall rules into one stack. And then if you look at Kubernetes, I may have a stack for the Kubernetes cluster, for the control plane, and different stacks for the individual node pools, but it really depends. Some hints could be, for example, look at different providers. Typically, you want to have as few dependencies as possible when it comes to connecting different providers. Environments would be another approach. So for example, you could fan out stacks based on environments. You can have stacks for staging environments, for production environments, for dev environments, and even within those environments, you can have substacks for sure. For example, a stack for the database, stacks for the VPC, for the Kubernetes cluster, etc. What we see quite often is stacks that are grouped around business units. So, for example, what could be different business unit, or how could you separate business unit? Typically, an application development team from a data team. whereas data teams deploy very different applications and follow different paradigms than application developers. It sort of makes sense to look at the infrastructure in a different fragmented way. Or different regions. Different regions could be, for example, depending on, let's say, we use Google Cloud as an example, Europe as 1, Europe as 2, and whatnot. Those are typically perfect scenarios to split your Terraform state as well as code. So then, as Terraform sort of lacks the capabilities of stacks, right? Terraform is workspaces, whereas workspaces fundamentally differ in Terraform CLI to Terraform Cloud, and not everyone is using Terraform Cloud. Typically, you want to onboard some sort of third-party tooling. So now I'm obviously highly biased by being the author of a Terramate. There are different tools in the market. For example, TerraGrunt would be another one, which is also an excellent tooling. I think the main difference here is that TerraGrunt is a wrapper around Terraform versus Terramate is an orchestrator, means you can execute every command. With Terramate, it doesn't really depend on Terraform. And I want to show you some examples after this, but basically after the slide, Terramate helps you to maintain highly scalable Terraform projects, and it adds capabilities that in order to scale Terraform CLI are from our point of view necessary. For example, stacks be one of them, code generation, which I will also show in a minute, change detection, orchestration, whatnot. We're a member of the CNCF and the LLF, and yeah, pretty deeply involved in the ecosystem. Again, more than happy to answer any of your questions after this. Okay, let's jump into the demo, and hopefully you can still see my screen. So I just want to show you some of the challenges and how to overcome those with stacks. So if we look here, sorry. If we look here at my IDE and I'm using VS Code here, you can see basically there is a directory tree on the side, whereas I have a directory called stacks. I have a directory called imports, and then on the root, the most important, I believe, is this config.tm.htl. And you can see I basically have 3 different stacks within this directory tree. So to give you some sort of context, in this config.tm.htl, I basically just put this there. I basically define what we call globals in Terramate. So globals is basically data, global data that is shared and inherited throughout your stacks hierarchy. It can be extended, inherited, or overwritten. And it basically just helps you to reuse data in an amount of stacks. So what you can see here is that basically I have a Terraform version defined in this config.tm.htl. I have an S3 bucket defined here. Basically, we would use S3 to store our Terraform state here as the remote backend. And then basically, I define a version for the random provider in Terraform. Then I also have an import directory. And that's something that doesn't exist in Terraform natively. So what I do here is basically I have 2 files that help me to code generate, to generate code for the Terraform backend and providers configuration. By the way, I have this example. Let me just quickly show this to you. I have this example also here available in our GitHub organization. Examples, just so you can also make examples. You can also revisit this if you want to. I created this some time ago, but it's all in our GitHub as well. So basically, the code generation statement here helps us to generate a bunch of Terraform code, right? And we have a statement here for the backend. whereas I already said this would be S3 and for the provider. And what you can see here is that we substitute basically here in the required version, we substitute this global Terraform.version that I've already shown you here. And this at the moment is set to version 1.5.1. So now let's say I want to set this to 1.5.0. What I could do now is basically invoke a command that's called Terramate generate, and that in Terramate would basically invoke the code generation. It regenerates to be generated code that is managed with Terramate. So let's do this, and we can see in the code generation basically returns a report, right? And you can see that, okay, within our stacks directory, we have A stack, B stack, and C stack, and it regenerates this file that we have named here, by the way, Terramate generate provider. So let's look at this. You can see basically it generates Terraform provider configuration for us. Let's assume we want to set this back to 1.5.1. If I rerun the Terramate generation and I take another look at this file, this would be updated again to 1.5.1. And the interesting thing here is, which is important to understand, is that I have this config defined on the root level of my project, right? So now I mentioned early on in this call that globals are inherited throughout stacks here, but they can also be extended or overwritten. So let's assume we want to roll out another version, another Terraform version for only a stack. So what I can do, let's copy this and let's create a config here. We call this config.tm.hcl and set this to 1.6.0. So now if I invoke the code generation again, you can see by looking at the code generation report that only the code in the A stack has been regenerated. So you can see this here. If I look in B stack, this is the same version, right? And now this basically means if I have a directory here, one for different environments, one for staging, one for production, and I want to test the update to a new Terraform version for all stacks within a specific directory, for example, the staging environment, which can of course also contain multiple child stacks, stacks can be nested, then I could basically roll this out to the staging environment first, see if everything is integer and works before I roll this out to production. So now let's delete this file again. We run the Terramate generate again. It defaults back to version 1.5.1. One thing that I wanted to show you also is, as I have those statements here, there's import files declared on the rule. What I could do is I could basically say, hey, Terramate create stacks, and let's call this D stack. So now this would create a new stack for me, and this would automatically add those files here. And if I want to create a stack within a stack, I can also do this here by running Terramate create stacks, D stack, A stack. And basically this would create a substack, a nested stack, whereas in the order of execution in Terramate, we would always execute commands in the higher level stack first, so which would be the D stack here before going into the A stack. One more thing that I wanted to show you, why is this neat? And why are stacks so useful? So let's assume, and I'm using AWS Vault here to basically connect to my AWS account, whereas I use this for the state backend. If we invoke Terramate list here, you can see Terramate list shows us 3 stacks: A stack, B stack, and C stack. So now what I can do is, I can basically say, hey, Terramate run, and now run any command inside all of those stacks. Whereas the order of execution here would be A, B, and C. By the way, this can also be manually modified by using using configuration parameters here, such as append, before and after would be one. After I can basically overwrite the default execution, order of execution here. To come back to this, so Terramate run allows me to execute any command inside of stacks. So what would be a command that I typically want to run here? Terraform init. Now I need to log in, sorry, to one password. In order to have this running. This should run, I believe. Yes. So now what Terramate will do is Terramate will basically jump into all the stacks and invoke Terraform init in here. And the same, of course, I could do with Terraform plan. So this would basically jump into all those stacks and execute Terraform plan, right? More importantly, because we talked in the beginning of this call, now if we have a number of stacks and we only want to execute whatever, we only want to execute commands in stacks that actually contain changes, we could say Terramate run changed. So now what this would do is it basically looks at what stacks contain changes and only execute Terraform or whatever command. Of course, this could also be, I don't know, ping, in whatever stacks contain changes. And following such a paradigm, we can now basically split up larger environments or design environments from scratch that are split up by default. Execute commands in environments that contain changes only, and hence build more scaling ISC environments. I hope this could give you an idea. 30 minutes are finished, so I don't want to stretch more. Otherwise, I could happy to jump into more details, maybe in a follow-up session, or if you want to get some more input, more than happy to answer all your personal questions also after the session. Other than that, being grateful here and saying thanks for joining. Was great fun to talk to all of you, and now I'm more than happy to answer your questions.
Yay, let's jump into Q&A. Thank you very much, Sören, for an amazing presentation. I already see 3 questions popped up in the Q&A section, so let's go through them. How to upgrade AWS EC2 instance without destroying instance? Change T3 medium to M5 X large with destroying.
Without destroying. That depends. To be absolutely honest, I'm not 100% sure I can answer this question accurately, because it depends on the underlying cloud provider, right? This is not Terraform specific, because and for the EC2 instances, I would need to look this up. But typically, there are operations in all the major cloud providers that either allow you to update resources that are already deployed on the fly. And typically this would be stuff such as volume size. Versus if it's a destructive operation, it would cause recreation. And that's typically, for an example, changing the underlying network. Example, in Google Cloud, we cannot change the underlying network of the Kubernetes cluster without redeploying the whole cluster. So to be honest, that's nothing really Terraform specific. It pretty much depends on the Terraform provider of your choice and the resource that you're trying to manage.
Cool. Nice. Another question from a chat. Are you using a database to keep the state in sync for multi-user setup, or does Terramate do it for you? Yes,
that's a good question. So typically also very much depending on your setup, Terramate doesn't store the state for you. All the Terramate does is it adds a few missing capabilities to Terraform in order to make it more usable and more scalable. the state is typically stored in a remote backend versus that to lock the state. That is also nothing that Terramate does for you. Okay, now you just corrected your question. It's not about syncing the state, but locking the state. No, Terramate doesn't lock the state for you. We rely on native Terraform capabilities versus in most of the times it would be if you manage your state in S3, of course, DynamoDB. Yeah, I believe in OpenTofu, by the way. We're adding more native capabilities to lock state. It's been requested in Terraform many times. That's probably also why you asked this question. I don't really see Terramate being responsible here. I'd rather point to OpenTofu. Check out the repository. By the way, the roadmap looks really great, and the team working on this is also pretty sophisticated. So maybe worth checking out for you.
Nice. Does Terramate allow to pass values between stacks? For example, I'm stack B and I want to use the output from stack I.
Yes, that's the most common question that we see in the community. And that alone is worth a session. So the way that we look at it is, right, what you're asking basically is how can you share data from one stack to another with another in Terramate or with multiple others in Terramate, right? The common pattern here that you probably know by looking at tools such as Terragrunt is to use outputs, right? So now, why does Terramate discourage the usage of outputs? Outputs are a contract, Terraform outputs are a contract that are persisted in the Terraform state file. That means they may be stale. Yeah. That also means if the contract gets changed, all of the consumers that use these outputs need to change its implementation. Yeah. So what we do in Terramate is basically we recommend two patterns. The first would be to use globals to inject data to be used in different stacks. That is top-down data sharing, which I already mentioned. The other one, different to use model outputs, would be to use data sources, yeah, whereas data source would issue an API call to the resources of your choice in order to query the data. If data source is not available, because data source depends, of course, on providers. If a data source is not available for the target data, we would use remote state lookups instead. So in fact, we discourage the usage of outputs for either top-down data flow, which would be global, or data and data sources and remote state lookups. Hope that answers the question.
Nice. Thank you. Great session. Interested to learn more about when will be the next session, I guess. You have to give
so that depends on you, Maria, I believe. Guys, I'm more than happy to go into more detail. What I would suggest is what would be helpful if you post in the platform engineering Slack in the Terraform channel what you would like to see covered within the next session. We can definitely structure this and make this happen. I believe there's a great roadmap of talks ahead, but maybe we can squeeze something in. So just tell us, what you would like to see covered in the next session, and we'll definitely address this ASAP.
Exactly, amazing. Next one is more towards career path. If you were, you would give yourself. Jill is asking, I've been more in system admin for the past 4 years. Now I'm switching to DevOps. Which path would you recommend to follow? There is a lot of information, and they did masters in computer science.
Yeah, career advice. So I'm self-taught. I don't have a bachelor nor a master's degree, although I tried multiple times. Learning by doing, and always learn by real-world projects. So books are good, tutorials are good, but I think the best thing you can do is just learn by doing. Try to break down huge knowledge silos into smaller steps, similarly to what you do with stacks. Definitely learn cloud native technologies, learn technologies such as Terraform or even Pulumi. Pulumi is on the rise. It's a great technology as well. More developer centric. Look at Kubernetes. and make sure that you can land an entry job in this field ASAP to basically get going, because I believe, yeah, you can educate yourself for many years, but nothing is better than field experience. By the way, if you want to talk, feel free to reach out to me. I'm more than happy to jump on a call with you as well to give you some more fine-grained advice.
Very nice. Thank you, Sören, for suggesting it. Next question. What scenario do you think this feature, stack run orchestration, would be helpful? I guess there is the correction, so you might want to check out 2 questions. What scenario do you think this feature would be helpful?
Which feature are you pointing to? Sorry.
Stack run / orchestration, what I understood.
So stack run / orchestration. So I'm not sure I understand this correctly, but typically what orchestration means, orchestration just means orchestrate the order of execution of stacks. What you can do with that, for example, in Terramate, we also have the concept of stacks, of tags. So the orchestration could help you to execute Terraform in stacks that contain infrastructure to deploy network and Kubernetes cluster, but stacks can also contain Kubernetes manifests. We don't market Terramate like this for now, but as it's not a wrapper, but an orchestrator, you can also, execute kubectl in all stacks that contain a tag Kubernetes or so, in order to then deploy applications based on Kubernetes manifests within this newly deployed cluster. Yeah, so an advanced kind of concept. If you're interested in learning this, I'm more than happy to provide an example here as well. And I hope I could answer the question, because I'm not sure I understood it properly. So if I did not, then please rephrase, and we'll address it in a minute.
Amazing. Thank you. I'll take one question from the chat, since there is one. How can we use on-prem server using Terraform you have set up?
Yes, I will. I'm not sure. I'm not sure how that question relates, but I believe the question relates to if we can manage on-premises infrastructure with Terraform. Whereas the answer would be, so what Terraform does is, Terraform is a wrapper, right, around APIs. Hence the concept of Terraform providers. Terraform providers are nothing else than Terraform mappings onto different APIs. So now if you use a cloud provider, that provides on-premises hardware that is manageable with an API, you may want to check Terraform providers, and I'll share this here in a second. So this would be a registry at terraform.io, browse providers, to look whether or not your cloud provider of choice is supported. If it is, you'll find some examples there on how to deploy and manage instances within your provider. If not, the possibilities would be to come up with your own provider, or to basically implement a provider, or basically eat your own dog food, because a lot of the on-premises providers don't have sophisticated APIs in order to manage their infrastructure programmatically.
Cool. Next question. Stacks seem to imply that you're keeping your Terraform all in one repo. But what about when you have many repos, one per microservice? What benefits could stacks provide in that kind of setup?
Yeah, that's a great question. And a pattern that we see here quite often is, for example, you would have one repository that managed kind of the base infrastructure provided by a centralized org, staff, or even platform team that is shared and used by different teams, versus the individual teams then manage their infrastructure for whatever services they maintain, aka let's call it microservices, in their individual service repositories. So now the message here is, if you fan out into multiple repositories in order to move the ownership of infrastructure that is owned by services to the individual repositories, I would say decide on the complexity of this infrastructure. If it's simple infrastructure, if you just need a database and maybe a few secrets or so, you may don't need to use stacks because it scales. If it's complex infrastructure, I think stacks can easily be used, or should easily be used and applied in order to profit from the mentioned upside, such as shorter CI/CD runtimes, change detection, limited blast radius, whatnot. If you need to use data that is defined in your shared repository within those individual service repositories, that would directly relate to the data flow that I mentioned. So either you would use globals here, which then of course would be replication of data, non-ideal, versus you simply use data sources and remote state lookups in order to query whatever data you need within those repositories. Happy to provide some examples here as well, by the way, if you find this useful. Just feel free to ping me in the platform engineering community.
Yes, and let me post a link once again, since we are referencing it a lot. Please join in Slack. As Sören mentioned, there is a Terraform channel, and if you have ideas, topics you would like us to dive into in the next session, that's the place where you can put in all of your requests. And I will move forward to the next question. What is this? Why is this a separate project versus OpenTofu module, or are you hoping this gets integrated?
Yeah, that's a good question. So basically, Terramate has existed for 1.5 years here. Yeah. So previously, prior to OpenTofu, my honest belief is that the community contribution to Terraform were very limited and little, for the fact that HashiCorp didn't really accept any community-driven contributions. They were just following their own roadmap. Will Terramate or any other tooling, Terraground is also very well known, be back to OpenTofu? My personal belief is that it shouldn't, for the fact that it's none of the core competencies of Terraform itself. So I personally wouldn't diverge too much between, let's say, Terraform Classic, which is what OpenTofu really should be, and Terraform. I would still leave this to the individual project. But to be transparent, I of course also have a commercial interest, because I'm building Terramate Cloud, which is building an extra layer of UI and drift detection and alerts and querying your stacks and whatnot on top of Terramate. So I don't think that Terramate will be contributed, or core competencies of core functionality of Terramate will be contributed to OpenTofu. Can I prevent that similar functionality will be added there? No. And by the end of the day, I think it's a community-driven project that the governance is managed through the CNCF itself. So more than happy to follow whatever the community think it's best.
Nice. Next question: how do you compare to Atmos tools?
I haven't used Atmos, to be honest. Cloud Posse's Atmos. I really can't comment on that. What I believe, though, is that the main difference here is that Terramate is an orchestrator and code generator. It means we always generate native Terraform code. It means that whatever you do with Terramate is always executable in Terraform Cloud or Spacelift or whatever CI/CD provider or third-party tooling you use. I'm not sure how Atmos works exactly. But I think it solves a different kind of problem in the sense of adding strong conventions to the existing Terraform project. More than happy to look at this also after the talk and to give a more fine-graded and detailed answer in the community.
Awesome. And the last question we have here in the Q&A: can order of stack orchestration be ascertained by Terramate automatically to understand the order of execution by Terramate instead of developer defined? Yes,
definitely. So there are, let me look at this quickly. So there are different commands in Terramate. I'm quickly going to share my screen. So basically we have here run graph, which will provide you with a graph. We also have Terramate run order, that's experimental, which will basically show you the order of execution of different stacks. And then if we look at, I haven't looked at the documentation for some time, but if we look here at the previous stacks, so if we look here at the stacks configuration itself, you can see that stacks can have tags, stacks can watch other stacks, stacks can be can have an explicit order of execution with after. be before end one, so you can influence the OLAF execution by that. But yes, to answer your question, if you want to see the run graph or the run order, we have built-in CLI commands to do so.
Cool. Well, you guys type in your last questions if there are still. If anyone goes to KubeCon in Chicago in 3 weeks, I would like to invite you to the House of Cube, the hottest party in cloud native. Please RSVP as soon as possible, especially the platform engineering community, since we have like limited capacity. But yeah, everyone who is interested in a little bit of party before the event should definitely join in. Sören will be there as well.
Yeah, I will be there as well, and would love to meet all of you in person for sure. Other than that, thank you so much for the time, and Maria, for giving me the opportunity to speak here today. It's always a pleasure with you guys, and looking really much forward to the next session. Have a good evening or afternoon or morning, wherever you are.
Likewise. Yes, thank you very much, Sören, and hope the rest has an amazing rest of the day or end of the day. We'll send over the slides and webinar replay to everyone tomorrow. And you can also check Platform Engineering YouTube channel for all the previous talks. We usually have this weekly, and sign up for all the new ones. But with all of that, hope everyone is safe wherever you are in the world, and have a nice end of the week.